I don't know. Maybe on break still? Happy Tuesday. So, I'm mentally on break still too. It's okay. Okay. We'll get there. So, and that's okay. You know, some people like to in person. Some people want that flexibility.
Constantly keep crashing.
What crashes on the computer?
The network connection was lost, reconnecting, and it crashes and shuts down and logs out.
I mean, they're plugged in. It shouldn't crash. No, I can. Yeah, I can send that to IT.
It's every time we try to get in, it get on desktop.
Is it more than just that PC, or is it just that PC?
Oh, it's like some of them.
So I wonder if that row has like some loose cords. Yeah, we can have a look at it.
Well, that sounds.
What's the there should be like a sticker on it that says ORG119 and then a number, like a white label.
ORG 119.13.
119-13. Okay. What other one does it happen to?
It has happened to 12.
G119.12. Should be 14. Okay. You're getting a network connection.
There's only like 8
Okay. All right. I will turn that in a little bit later to IT. Yeah. Sorry. You could try the other row up here, I guess. Or
it does it like once and then it's stupid.
Yeah. You're probably kicking the cord under the table.
Take the computer off.
Well, it's on top of the table, so kicking it off is going to be a little trickier. That's not a challenge. All right. So welcome back from break. We are actually near the end of the regular content before we get into graphical user interface programming. So we have tonight, and we have next week, and then we've done everything we need to up till GUI programming. We'll have the midterm review and exam week. I don't plan on coming this week unless you want me to watch you take the test. I'm happy to do that, but you don't need me to watch you take it. It's open book, open notes like the quizzes. It's not timed. It just has the due date. So open it like the quizzes, look at it, come back to it later. As long as you get it in by the due date, we're good on the midterm there. So that's the plan for that week, and this will cover all the general topics we need. Then we'll come back, get into graphical user interface programming, talk about our final project. Hopefully you've met some classmates and you can pair up with somebody. I think it's a little bit frustrating sometimes to work with a partner, but generally your end result will be better because of it, because you have two people bouncing ideas off of each other before you even start writing code. And I think you've learned by this point, if you don't really have a solid idea of what you're supposed to do and you start writing code, it goes very badly. But if you have a nice solid idea, okay, this is what I want to accomplish, these are the steps I'm going to take. If you kind of can do this like in English, hey, I need to do this and then do this and then do this, and then you can translate that into code, it comes out a lot better. So having a partner, you can kind of plan out the idea of what you're going to build before you even build it, and talking to someone else about it usually helps a lot. So that's the plan there. And then these nights, this week is not super heavy. We don't get into everything in Chapter 8. We get into some of the stuff in Chapter 8, so we'll have time to work with your partner. When we do GUI programming continued, we don't even get into all the stuff into this chapter, and you'll do more graphical user interface programming in the 2151 course. If you continue on, take another Java class, you'll do more of it. So these weeks here are meant to be a little bit lighter, so you have time to work with your partner. Generally, I don't do much for labs. I'll do the first GUI lab. We'll have a starter lab to make sure everyone can get a program up and running, get it working, put a button in, and you get hello world, essentially. After that, I don't plan on having labs for week 13 or week 14 because I want you to have the time to work on the final project. Like that's what we're doing. So practicing the stuff is, I don't know, it's a little rough sometimes if you also have the project to work on. So we'll do that. And then 418 is just final project work time. I have no plans for new content. So I'll show up and I can wander around the room and help you get you unstuck if you're stuck on something in the group project, with the final project. And then on 425, instead of a final exam, I finally shut up and you folks get a chance to come up here and talk. Or from your computer, hop on Zoom and share your screen, or however we want to work that out. We'll figure out a way to make that work, whether or not you want to come up here or just run it from where you're sitting. And so everyone is going to solve the final project differently, and it's going to look a little different, and it's the same project, same assignment, but because it's a graphical user interface program, everyone will lay it out and design it differently, which is really interesting to see. And this idea of user experience or user design or human-computer interaction is a whole specialty subject you can get an entire like master's degree in if you are so interested in human-computer interaction sort of stuff, which is really neat. I'm terrible at that sort of stuff, and I will just admit I'm terrible at it. I would love to go learn more. I've had a lot of things I'd like to go learn more about too. So I'm not going to make anything pretty. You are welcome to make it as pretty as you want. I will show you something really ugly that is an example layout, what it might look like, and a lot of people just copy that. Well, that's fine. You don't have to change. You don't have to make it look nicer, but that's an option for you if you want to do that sort of thing here. And then that is the end of April, and we're done with the winter semester. So fall registration, I think, is opening shortly. Does that ring any bells? This week? No, I'm sorry. Summer. Then fall is also getting posted like in 2 weeks, so you can also register for fall shortly as well. The whole big thing about that, but that's fine. Should be a lot of fun. And then there is the Summer Momentum Scholarship. Momentum. I posted in Discord about it a while back. Momentum. Oh, look at that. Is that in my history? There we go. So up until April 21st, you can apply. And if you've taken classes over the winter semester, and I think fall, I should actually read this here. So if you've done more than 16 credits or have completed them by the end of winter, then you can apply for up to 6 credit hours worth of scholarship money if you're taking summer classes. OCC really wants you to come in the summer, so they're going to help pay for some classes to get people to come in the summer. Other sorts of requirements, sure. But yeah, go check that out. It's in Discord in the OCC general info section somewhere in there. Every time I get links for stuff, I post it. So, or just search Summer Momentum Scholarship. You should be able to find that one. So if you have plans for summer, great. If not, that's okay. We'll still be here in the fall as well. So that one's coming out soon. All right, pull up intelligence. We got to do the lab first, right? So we go pull up the lab assignment. We'll go over that. Now, if this went badly for you, the project is likely to go badly, right? Because they're very similar in idea here. We're writing a class, we're testing the class. Our methods do very specific things, right? If the lab went really well for you, the project should go really well for you. Sort of the thought here for this classes and unit testing here. So let me go edit this one here. So we're going to build our bottle, drink, and fill unit tests. So we already talked about the bottle class. Now we're going to go write unit tests for them. So we had the lab 5 as our starting point here, right, which had the bottle class. And I started the file for bottle tests. I didn't actually do anything here. Right? This idea that I want to test that drink is successful. Because one of the things that drink should do here is, if it's successful, I'm going to return a true, and my current volume should change. If it's unsuccessful, right, this other test here, if it's not successful, then my current volume should not change, and I should get back a false. Right? If I want to drink 1,000 milliliters out of this bottle here, it should tell me, no, you can't do that, return false, and not change anything. Right? If I want to drink 5 milliliters out of this bottle, it should say, sure, go for it, and it should take 5 milliliters out. You can take a sip. If you want to drink this teaspoon by teaspoon by teaspoon, go for it. You probably drink more than 5 milliliters in a sip, but I've never actually measured. Now I'm really curious because that's where my brain went. Like, how many licks does it take to get to the center of a Tootsie Roll Pop? How many sips does it take to get to the bottom of a Coke bottle? No? You guys never saw that commercial, did you? It's okay. All right. So, I think the owl said 3, right? Traffic does suck. Welcome in. So 696, like, is going to be under construction for ever, right? I don't know how, like, all summer long for this, right? Because they're redoing the whole thing on 696. So, sorry, that's going to suck getting here. I don't have the street roads any better because, like, a lot of people take the street roads now to get off 696.
They take just as long.
Just as long, yep.
But construction. So.
Yeah. Eventually, it'll be nice. So 96 have been under construction by my house for a while because they're going to put the flex lanes in. And
This is
sure,
the first time I'm seeing them working on it.
actually working. Yeah. Well, they started closing it off early to prep for work because They like to have it closed an extra week because that's fun, right? All right, and that's the joys of driving, right? I can't wait till cars drive themselves and I can like be productive in the car. My wife refuses to get in a car that drives itself because she sees when I write software how well it works. She's like, "You trust that to drive a car?" Like, yeah, why not? So actually, I trust the cars more than I trust the other idiots on the road. Of course, will drive better than the autonomous vehicles, but all the other idiots on the road, the autonomous vehicles will drive better than them, right? I don't know. It'll be interesting. It'll be interesting. All right. So, two things happen with drink then, right? So we're going to test both this idea of code coverage. I want this line of code to run when my tests run, and I want these two lines of code to run when my tests run. I don't want to pay a bunch of money for a fancy tool, so I'm going to eyeball it. So I know that I need this to be true, and I know I need this to be false at some point in both of my tests. That's why I have two tests here. I have the successful and the unsuccessful. So we're going to follow this AAA format, right? So we're going to arrange the variables we need. Then we're going to act. We're going to call the code we're testing, and then we're going to assert, did we get what we expected? So if drink is successful, so I need a bottle to drink from. So I'm going to make bottle equals a new bottle. And bottle needs three things, right? I'm going to look at my constructor. I need the max, I need the current, and I need the beverage name. I don't care what the beverage name is. So sure. So why don't I make some variables? So I have an int for, this is the current milliliters in bottle. Sure, I will say, how about 100? Why not? Now, that can also be the max, right? It can start as a full bottle. So I'm going to use that twice because I don't want to have to type more than I need to. And for the name here, I don't care. I'm just going to give it quote, quote. It's an empty string, but it is a string, so Java will be okay with this. You can't just exclude it here because now it's going to yell at us and say, hey, cannot resolve constructor bottle int. There is no constructor that only takes an integer and an integer. The constructor for bottle takes an integer, and a string. Those three things. So sure, so we'll give it a third string. We just don't care what it is. Doesn't matter. So I set up my bottle. Okay. Now, if I'm going to drink from it, how much do I want to drink from it, and what do I expect to have left when I drink from it successfully? So I'll have an int expected milliliters. Should I zoom that in? I'm sorry. Let me zoom that in a little bit for you. Milliliters in bottle. So we start with 100, and we're going to drink some. How much is going to be left? This is the audience participation part. So I start with 100 milliliters. I'm going to drink some. We'll have 20 left. Okay, sure. We'll have 20 left. We can do that. I spelled milliliters wrong, I guess, right? There we go. All right, cool. So these are the variables I need. I'm setting all of these up. I've arranged everything I need for testing. Now I'm going to act. Now, drink will give me back a Boolean result, right? It's going to tell me a true or false value here of yes, it worked, or no, it didn't. So I need a Boolean for the result here will be my bottle.drink. Now, a lot of folks had some questions here. I'm using my instance of bottle that I created here, not the bottle class. And this is why naming is important, right? Classes start with uppercase letters, variables start with lowercase letters. We like naming them the same thing because otherwise it's kind of annoying. Like, this is just a bottle. So it's lowercase bottle. This is my instance of bottle that we created, .drink. Now, if I have 100 and I want to end at 20, how much do I need to drink? 80. Thank you. All right, so we'll drink 80. And then we need to get the current value, the current volume in milliliters from the bottle. Say, hey, bottle, I just drank out of you. Tell me how much you think you have left. I think you're going to have 20. Let's find out. So this will be the actual milliliters in bottle. Is my bottle dot get current volume in milliliters. I can't spell milliliters. This is the problem. This is why I should use, I don't think I can spell ounces either. That's all right. Now we're going to assert. Now, two things we can assert. One, that the expected milliliters matches the actual, and two, that result is true. So if something's true, it's just assert true. We'll say my result. I expect this to be true. If it's not true, it's going to fail on me. The test will fail. And then I can assert equals the expected milliliters and matches the actual milliliters. Right? So we've created the bottle. We drank from it. Now this should be how much is left. So let's give it a run. And if it works, we get a nice green check mark. If not, we get the nice red or orangish X. A green check. It worked. So we were able to drink 80 and have 20 left. So for the failure, it's basically the same thing, but we're going to give it a different value. If we want to be unsuccessful, if I start with 100, how much should be left if it fails? 100. It shouldn't change, right? So my expected is going to be 100. Shouldn't change. So if I want it to fail, I need to drink more than I need to attempt to drink more than I have, right? So let's take the current, I don't know, +1. We can give it in, you can put in 1,000, it doesn't really matter here. But this way, if I ever change current, it's always going to be +1. So like, if I want to change this value next time I copy paste, it should be okay. Now, I don't want to assert true because this should tell me false now at this point. So I'm going to say this is assert false. And then my expected milliliters is 100, should match what's actually in there. If I try and drink 101, it should tell me no and not change anything. So there's not that much liquid in the bottle to drink, you can't drink it. Don't try. Which maybe we would just chug it anyway and then not have enough liquid and be sad, but that's okay. We're just this is the code we wrote. So let's give this one a try. All right, and that one, there it goes. Now it passes. So if you just click one test, it'll run one test. If you go back up to the top, you can run all the tests, or you can right-click and run tests, and you got lots of options for running these things. Yeah, your question?
When we add the when we add the test to our library, we want to use JUnit 5.
JUnit 5, yeah, 5. Whatever is the latest version. 4 should work for you, but 5 is the latest version, and I'm just a fan of latest versions. Yep. Yeah, so pick 5 when you create the tests, and that should work for you. So you'll notice it said fill passed. It's a little weird to me that in the absence of failure, it marks it as pass, but that's the way that these tests work. So just because it passes does not mean we're done, right? It's empty. Hopefully that's obvious here, but some people are like, hey, my test passed, I'm done. And I just like scratch my head for a minute here. So just be a little careful, and then sometimes you can just say assert, if it fails, you just like assert true and just put a false in or something. I don't know, you can do some silly things here if you want it to fail. Because this way now when I run my test, when it's empty, it will at least fail for me, and I can come back and finish it. This is a lot of overkill. I don't recommend that. But for this sort of thing, it's a nice reminder that it's not done yet. That's all. But we're working on it right now. So same with fill, right? Fill, just like drink, has a true option and a false option. If it's false, nothing changes. If it's true, it did change. Right? So we're going to do the same thing. So I'll have 2 tests here, and I'm actually just going to copy paste these and rename them here for successful and unsuccessful, because I think that'll make my life easier. So we'll call this fill unsuccessful and drink unsuccessful. Oh no, fill successful, sorry. So now at this point, the max and current matter, because when we're filling, we're adding to current, getting up to but not over max. Right? So I want to give it different values for max and current. Right? Okay, so I want another variable here then for max milliliters in bottle. We'll say maybe it's 100, and then I don't know, we could just start off at 0 here for that, sure. And so if I start off at 0 and I fill some amount here, how about 20? Well, land at 20. So I'm going to use my constructor and say here's the max now is 100. You start with nothing. Again, the beverage name doesn't matter. And now we're not going to call drink, we're going to call fill. And I'm going to fill 20, or I can just fill this variable here too, right? This value is 20, so 0 plus 20 should still be 20. Get my actual, and then 20 should match 20. My result should be true. It should work. Right? So let's give this one a try. That one passed. Right? So for fill unsuccessful, if I start with 100 and I have 100 at max, any amount of filling should fail. So I guess I can just leave it here, right? That's fine. And we'll just say, let's just fill like 1 or something. Right? It should be back false, and my value should not have changed. Right? I started with 100. I should still have 100 when I'm done, because I tried to fill it and there was nothing in it. Right? Or we could even change this one down to 50. Right? We could say, let's change this one down to 50. Why not? Oh no, then fill will fail. This is fine. This will fail. This should work here, right? We're not changing anything. I kind of wanted to like not have 100 in here, but it really doesn't matter. The code will run. Let's give this one a try. And that one passes. Right? So it unsuccessfully fills. It told us false, it didn't work, and my current volume didn't change. Right? Life is good. Does that make sense for what we're doing testing here with bottle? So in terms of code coverage, we never used the set max. I don't care all that much about set and get methods. They're nice. Depending on how you do it here, your constructor might also use the set method anyway. Right? Like instead of just saying, hey, my max equals max here, I could call my own set method, which is useful if your set method does some sort of logic, right? We totally skipped on this, but set max should probably make sure it's a value greater than 0, right? You can't have a less than 0 volume because of the laws of physics, right? You can have a 0 volume, right? That's just, it'd be a solid bottle. You can't pour anything in it if it's a solid. Sure, 0 is okay, but less than 0 just doesn't work. So we could add that sort of protection to our class, and that's one of the things classes are meant for, is they're supposed to protect the integrity of their class, right? So that you can't have bad values for max. Because if your max is a negative number, you're never going to be able to fill the bottle. Fill will always fail, right? Because it can't add anything to it because it's negative. So that'd be a good thing to add. We just didn't get into it at this point, so that's something that'd be nice. And then other sanity checking that we could do is making sure that the current here is not larger than the max. So we might actually just use the fill method here instead of just setting it to current. Because right now I can say, hey, the max is 10 and you currently have 1,000. And the constructor just says, sure, I'll take your value 10, I'll take your value 1,000 and take them. We have all this other code that we wrote here, right? We wrote fill to make sure that doesn't happen. So we could go set max with our set max method. Now let's do that. So we'll say, well, set max volume given the max volume in milliliters. And let's make set max do the sanity checking here. So we can say, hey, if the max volume in milliliters is greater than 0, let's set it here. Otherwise, we'll say this max volume in milliliters, I don't know, we'll just leave it to 0, I guess, right? If you give me a value less than 0, I'll just stop at 0. Sure. So if you want negative 10, you just get nothing. You get 0 here. So we're sanity checking that. Then instead of just setting the current here, we'll just call fill. We'll say, hey, let's fill the bottle up given the current volume in milliliters. Now, this is actually not going to do what we want it to do here. I think it'll be okay because current volume in milliliters has never been set. It's actually going to start at 0. So it's probably better if we explicitly say, hey, let's start at 0, and then we'll go fill it up. No, this dot, sorry. The constructor's job is to give values to your attributes. So I'm going to go and set the value of current volume first to start at 0, and then I can fill the 0 plus something will be there. It's going to work without it because it's going to default to 0, but relying on that's a little bit ugly. It's not a very good practice to rely on the defaults. Your constructor should explicitly give values to things because we want to see that in code and know that, okay, I didn't forget something here. So relying on defaults is a little ugly here. Does that make sense why we changed these ones here? I mean, this is just a nice to do thing because these ones check. The other thing that we're not checking, what we probably should here, is did you give me a negative value for drink? Because if you drink a negative value, you can spit into your bottle, which is kind of like filling, right? Sure, you could give this a negative value, and we're going to say, hey, is the negative value greater than this? No, it's not going to be. So then when we subtract it, we're actually adding, because you're spitting into the bottle, adding more liquid. It's a terrible example. I apologize for that mental image. But, right, it makes sense. The class isn't protecting itself here. So we can also check then, right? We can say, hey, if it's greater than, right, or if my milliliters to drink is less than 0. Right? If either one of these is true, I'm just going to tell you no. Let's not do it. Right? Either you're drinking more than you have, or you're trying to drink a negative number. Because please don't backwash. I hate when my kids drink out of bottles and they backwash into them. Like, it's not hard to put your lip in the bottle, but like my one daughter just like puts the whole thing like right in her mouth. Come on, learn. Right? Do you want to drink your own spit? She's like, I don't know, it's my bottle. Just fair, I suppose. just weird. Little kids are funny like that. All right, so that one's good. And then same with fill, right? If we fill a negative number, we're actually drinking. Right? So we should probably sanity check that as well. So all of this, right? Or my milliliters to fill is less than 0. Now, in terms of code coverage, this line of code is still running. So I technically have 100% code coverage still, but I haven't actually tested that it works. Right? I've tested that my going over the max works, but I haven't tested that a negative will give me a false. So I'm not gaining that metric of code coverage by testing here, but it's going to make me feel a whole lot better that I didn't typo these things. Because it's really easy to get a greater than versus a less than, and then your whole code just is screwy. right? So I want to explicitly go test these, even though it doesn't gain me that number. And again, that's why like whatever you measure is what people tend to focus on, and it's a really weird game to play. Like if you measure productivity for people in lines of code, right? I'm going to say, okay, int bottle here, and then I can say current milliliters in bottle equals 100. I've just doubled my productivity here, doubled my lines of code. Measuring like lines of code to see how productive someone is stupid. It's something you can look at, but it's not a very meaningful number, right? So that sort of thing here. That's all. So just be careful what you measure. All right, so let's do some more tests here then. So let's do this is fill unsuccessful. Overmax is why it's unsuccessful. And they'll have another fill unsuccessful here. Oh, goodness. What do I keep hitting? I don't even know. Fill unsuccessful, negative value, negative fill. Sure. So if I fill a negative number here, it should just fail automatically and nothing should change. Does that make sense? Right? I want to test to make sure that that is working as I expect it to, because any code worth writing is worth testing. Okay, and now that works. So again, we'll do the same thing with our drink here. So this is drink unsuccessful over current, and they'll have a drink unsuccessful negative. Now, the reason why the names of these are important is because they show up when they fail or pass really quick. So you want to see what's being tested here just when it fails. So a lot of times, I think I mentioned this idea of continuous integration testing. When I check this into source control, I can make a cloud-based tool go and run the tests for me, so I don't even have to remember to run them. Or I can run the whole suite of tests for the entire project I'm working on, rather than, hey, I fixed one little component or I changed one component. Maybe it broke something else in the project that used that component. Right, so I want all of those tests to run, and sometimes they take a while, right? Depending if you have a lot of tests or not, it can take a while. So making the cloud run them is nice. This is negative value, sure. So if I just drink a negative number again, it should just fail immediately. And that one passed. So I feel good. So again, those were just nice to-dos. This is not part of the lab at all, but in terms of as we write a class that protects its integrity here, this makes sense because we want to make sure that these things are happening. And this is a little bit far to the side here, so I have to bump those down. And it's not like if you have to scroll left to right, it's usually a bad sign, but I'm zoomed in a lot, so you should be fine. I like to be able to see everything without scrolling here. And again, my set beverage name was never ran in the tests, but might as well use the set beverage name here, right? So I can just say, hey, set beverage name, given the beverage name. Doesn't hurt to use it. It's just an option. And that way I know that code is running when the constructor runs, is all. All right. Oh, goodness. There goes my cat. I should put this somewhere where it won't spill on my laptop, because that's going to happen given my luck this winter. I lost a laptop 2 years ago. My little guy got in my office and grabbed my cup of coffee and went to drink some, and it just all on the laptop. I was like, oh, that was sad. He doesn't even like coffee either. He just wants to drink it because I drink it. All right. Cool. So let me go commit this here. 1500. So this is lab 6, right? Was continuing the lab 5 bottle class. So if this makes sense now, the project should go really well. If this doesn't make sense, the project will go very poorly because half of the project is writing the unit tests, right? Write your electric vehicle car and then test that it does what it's expected to. Like drive and charge, you're basically drinking from the battery and filling the battery, right? Yeah, the question?
So for the project, what are we submitting? Are we submitting the test class?
The whole repository. You need the electric vehicle class and the electric vehicle test.
Okay, not main.
You can put anything in main that you want. I will ignore your main class if you have a file for main.
What you need is the electric vehicle class and the test class.
Yeah, so what you need to turn in is just the class and the tests of the class. Yep.
Sounds good.
Yeah, if you want to put stuff in main, go for it. Like we had stuff in main, perfectly fine. You're welcome to use main, and that's what we used to do for testing things, because like you want to see it run. You don't have to put anything in here. You don't have to get any user input. You don't have to ask the user for anything. Right? It's all I'm going to write the class and write unit tests to make sure it works. So I don't have to do this sort of thing.
Sure.
Right? The idea is maybe this class will be used somewhere else.
Yeah.
right? And we're not going to have some console-based input because no one really does that for most everything anymore. Console-based inputs, it's certain tools are really good for console-based input, but the majority of like what most people use is not that. If you were going to write a program that most people will use, so all right, ready for the new stuff? Awesome. That was kind of quick. So usually we take a break after lab, but I think we're okay to just power through. So this is, what week is this here? My goodness. Week 9? 9. This is arrays and array lists. Arrays are fantastic. Again, don't check this create Git repository box when you're doing the classwork stuff, because you already get a Git a Git repository from the GitHub Classroom workflow. If you check this box, it gets really confused because it puts Git inside of Git, and then Git doesn't know what to do with Git, and it's funny. Okay, so it's okay. All right. So everything we've done so far has been single variables, right? Where one variable can hold one thing. And then we said, oh, well, really, you can hold a class, and a class can have a bunch of attributes. Sure. So if I wanted to like get a list of test scores for the midterm, I could write a class that has 30 variables for test score 1, test score 2, test score 3, test score 4, test score 5, test score 6, and already you're bored, right? That's awful. We need a better way. So something you can do in Java is you can have a bunch of one kind of variable. And that means like a bunch of integers or a bunch of strings or a bunch of beverages, a bunch of bottles. You can have a bunch of these as a class as well if you want here in something known as an array or an array list. So array is the basic type. They're fast and dumb. Array list is the smarter type. It's more flexible and smarter, easier to use, I think. I prefer array lists. The syntax is a little funny. It uses a couple other characters that we don't really use for array lists, so sometimes it freaks people out. For everything we're doing, we can pretty much use them interchangeably. Not too big of a deal. The one big difference is once you create an array, the size is fixed. In array list, you can add to and subtract from, which is nice. So that's why I like them, because they're flexible. So to make an array of something, I might have int, and then you use the square braces, which is the unshifted curly braces here. So integer, open brace, closing brace. Says this is an integer array. We'll call numbers here. And we'll say equals a new integer array of, and then you can tell it how many values it's going to have here. So let's have actually 6 numbers here. So this creates an array. This is an array of type int here called numbers with slots for 6 ints. This is the new int 6 is the size here. Right, so I can hold 6 integers. Now, to get at those values, I use these square braces here, and then I like to call it index of, is how I read it. So I'm going to say this is numbers, square braces, index of 0, and we can assign a value here. Let's say, I don't know, 7. And then numbers, index of 1 is 13, and numbers, index of 2 is, I don't know, let's go 17. Numbers, index of 3, oops, that's this line here, equals 23, and numbers, index of 4 is, let's go 29, and numbers, index of 5 is 31. Now notice I said 6, but I have 0 through 5. When you deal with arrays, the first position or index is 0. So we always start with index 0. Now there's a really good reason for this. It's not going to make a whole lot of sense because we usually skip over the sort of idea of memory addresses and storing things in memory. But what happens when you tell Java you want to store an integer? Java asks the operating system for a spot in memory of 4 bytes in size to store that integer. And the operating system gets this location in memory, says, here you go, Java. Here is your memory address where you can store that 4 bytes of information. And Java says, great, I'm going to put a number here. Or I can read a number out of there. That's our integer variable. When you make an array of something, Java says, hey, operating system, I need the space to store 6 integers in one block of memory. So you get some block of memory here, like memory addresses always start with an X because they're in hexadecimal. It's not all that important, but that's okay. So you get 0 through 9, and then the letters A through F in hexadecimal. Not all that important, but just an interesting fact there. If you didn't actually read chapter 1, where he gets into some of that stuff, it's okay. So like this is 23F9. Sure. Here's some location in memory. There's a memory address here. You have, from here, we get 6 times 4. We get 24 bytes of memory, right? Worth of space to store. So numbers of 0 then is going to be at 23F9. Numbers of 1 is going to be this plus 4 more bytes. So 2, 3, and then 4 bytes from 9 is A, B, C, D. Again, it's not all that interesting, but that's okay. That's hexadecimal. And then 4 more bytes from there. So this will no longer be an F. Right? Once you hit F, you go to the next number. So this is 2, 4, 0, and then D, E, F, 0, 1. I probably should have started at a lower number here, but this is okay. And this is X2405, because that's an easy one to add 4. 2409, up to 24. And then 4 more, X2413. Nope, no, sorry, not a 3. 0, so 9, A, B, C, D again. D. There we go. D. So the operating system gives Java 24 bytes of memory here, starting at this address, going on through. So to find out where you're going to go read this value from, when you say, hey, I want index 3 here, Java says, okay, numbers starts here, go add 3 times the size of an integer to this memory address. That's where this one exists. So you don't need to just add 4 and add 4 and add 4. You can do the arithmetic and say, okay, 4 times 3 is 12. What's this plus 12? And then if you don't like adding in hex, your calculator program in Windows has a programmer option here. You can put in hex numbers, and it turns on the A through F, which is really fun. So we can say, hey, this is 2, 3, F9. We can say plus. Now, 24 in hex is a different value because it's hexadecimal. You can't say 2, 4. So that would be 116 plus 8 more would be 18. And it's really ugly, but that's 24, right? So we should get out, oh goodness, what happened here? Oh, I hit times instead of plus. Oh goodness, okay. Let's try that again. So 2, 3, F9 plus 18, which is 24. Again, don't worry too much about it here. 2411. Uh-oh. I did something wrong in here. What? Yeah. Oh, this is 4 at a time. I think I did some math wrong over here. Well, so 8. Oh no, 24. Okay, yeah. Yep, you're right. So I was supposed to add 12. Okay. I need some more coffee. Okay, so 2, 3, F9 plus 12, right? Because we said this is the third address here. Third spot should be 3 times 4 bytes, should be 12. So 12 in hex, A is 10, B is 11, C is 12. So we'll say plus C, then 2405. And look at that. Okay, the math checked out finally if you do it right. Math, that's what I love about math. My kids have not embraced this idea that you can always check your work. And if it doesn't check, you need to do it again. And they're just like, oh no, I got it wrong. Like, no, that means do it again. Like, I don't know. That's probably what it is, yeah. I have to do it when I check their work because we homeschool the kids. Like I do a lot of basic math, but that's okay. It's all right. So 2405. This is very interesting, all well and good. You don't really care about it. That's okay. It's not super important that you understand, but we start with 0 because 0 times anything is going to be that starting address. And that's why we start with zeros for indexes. So hopefully all of this just helps solidify the first location is index 0 because 0 times something is the start of that memory address block. Because we get that much space. And that's why if you think back, we had Project 0 and Lab 0 because I think I'm cute and I will number everything like 0 because that's what we do in programming land. Sure, it's okay. Fun. Anyway, so we can have one block, one group of values here with a single variable, and I get it then by index, which is still a little bit slow and tedious, but that's okay. So what I can do is I can say, hey, user, how many test scores do you want to enter? Right, so let's make a scanner, call it keyboard equals a new scanner, given system.in, right? And then we'll ask them, how many test scores do you have to enter? Enter, question mark. Here we go. Oh, this is too big as Y. There we go. And then I'll have an integer for number of scores. Number of scores is going to be integer.parseInt, given the keyboard.next line, right? So we'll get that value. Now I have that value, I can make an array of that size. So if they say, hey, I've got 12 test scores to enter, I'll make an array of size 12. If they say I have 20 test scores, I'll make an array of size 20. If they have 30, an array of size 30. If you're teaching at a university, one of those freshman classes with 400 people, I'll make an array of size 400. I don't understand how that works, but that's okay. I always went to small schools, so like the 400-person class thing just blows my mind. How is it even useful? But that's okay. You might as well just watch a video at that point, right? I don't know. Sorry, education is weird. It's really weird. So I'll make the number of scores. So this is my integer array called test scores equals a new integer array. And now the size here is the number of scores. So whatever the user entered, I'm going to take that and make an array of that size. It's flexible. I can, whatever this value happens to be, I'll make that many. Java will ask the operating system for that much space, right, to store these values. Then I can say for int. Now, I like the word index. A lot of people will put I here, and it drives me nuts because it's not hard to type index. I is very common. Most people will use I. I think it's lazy, so I always make fun of people who use I, and that's okay. So say index is 0. Index is less than. Now, I could just say number of scores, but the right thing to do if you're looping through an array is to use the array's size or length. So arrays have a length. So I can say test scores.length. The length is an attribute here of this array variable. It will tell you how long it is. How many items does it have? So the length of numbers here is 6. The length of number of scores is, the length of test scores is number of scores. But if you think to indexes, right, you have 0 up to but not including that number. So int of size 6 here was 0 through 5. So my for loop here starts at 0, goes less than the length, because there is no index at length here. The last index is length minus 1. Right? So if I have 20 scores, I'm going to have indexes 0 through 19. So we always go less than the length here. And then at the end of that, we'll just take index plus plus. So I'm going to loop as many times as this array length is, which is the number that they just entered. Then I can ask them. So enter score number, and then we'll just append in here the index. We'll just do 0 based too, right? What's score number 0? What's score number 1? Score number 2? Score number 3? Score number 4? Sure, why not? So we'll have an int for score then. And really, we don't even need to store that. We can just say test scores index of index equals integer.parseInt given the keyboard.next line. Keyboard next line. Next line. Too many parentheses there. There we go. Excuse me. So the test scores array at index, which is 0 and then 1 and then 2 and then 3, right? This for loop is going to increase index here. I'll go get the value and store it. Now I have a bunch of values stored in that array. Now, if I just want to print test scores, let's see what that looks like. We'll give this a run here. All right, so how many test scores do we have to enter? Let's just do a small number, like 3. What's score number 0?
100.
100. All right, you got 100. Good job. What's score number 1? 94. All right, still an A. 94 is an A. All right, test score number 3 or number 2? 20. Ooh, that was not a very good score. Oh, printing test scores gives me garbage. Right? You can't just print an array because the array itself is a memory address. So the memory address of this array is 79FC0F2F. That means nothing to us, but that's the memory address on my computer when the program runs that was assigned to test scores. So we tried to print it and we got garbage. Not useful. That's okay. So if you want to print the values in the array, you have to loop through it. So again, we could do another for loop here. There's also a for each loop, which is a shortcut because the one thing programmers like to do is be lazy. Right? I don't want to do more work than I need to. So I'm going to say for int value : test scores. What this does is it's going to loop through test scores. Each time I get a value out, I'm going to call it the variable named value. So I can print out value. Now, this isn't going to give me the numbers back out, though. I'm not going to get score number 0, score number 1, score number 2 back out. I'm only going to get the scores value that I entered. So it might not do exactly what we want here. It'll print these scores out, but it's not going to name them for me. This was test score number 0, test score number 1, test score number 2, because I don't have a 0, a 1, or a 2. All I get out is the values here. So if you do want to get the values back out here, and you just do the loop here, we don't need to print anything. I'm sorry, we don't need to ask for input here. We can just say score number index plus maybe a colon here plus my test scores at index. So when I put the square braces, I read that as at, so at the index of index. This could be at the index of 5 or 6. Like you can put a number here, but when I'm looping through it, I want to use the index variable in my loop because that starts at 0, goes up to, but not including the length. So I'll get every value out here. Right, so now I get at least a prettier looking output here. It's going to tell me the test score number 0, test score number 1, test score number 2, and then the score. This one just shows the scores without the test number, right? Or score number, right? Score number. And that's okay, right? If that's all you need, that's perfectly fine. So let's give it a run again. So we had, what, 100, 94, and 20? 100, oh, I'm sorry, so 3 test scores. I want to do 100, I want to do 94, and then 20. So the first for loop that we did here, the longer one says score number 0, score number 1, score number 2. That's pretty. The next for loop, this for each loop, which is the shortcut one, just gives me the scores. That's okay. Not too big of a deal. Now, I just entered them, so it's kind of silly to print them back out for the user. We're just kind of doing this to illustrate. But what might be nice here is let's calculate an average. Right? So if I'm going to calculate an average, I need to add them together and divide by the number that we added. Right? That's our basic arithmetic here. So I need an int for the total. Now, total is going to start off at 0. As I loop through, instead of printing the values here, let me bring that back down, sorry. I can take total plus equals the value. So I can loop through each value in that array, add it to the total. Then when I'm done, I'm going to figure out what the average is, right? Take the total divided by the number of scores. Now remember, if you take an integer divided by an integer, you're going to get an integer result. So our shortcut here, we could just say, hey, total should be a double. Because if I take a double divided by an integer, I'll get a double result. I'll get that decimal place. Because maybe it matters that the average was 79.2 versus 79.9. I don't know. Everyone always seems to care about the point number in your scores when I submit grades because you want to get rounded up. You're like, look, I had a 0.5. I can round up. Sure, why not? So if you have an integer, there is no decimal place. So might as well have the decimal place. So now my double for average, again, I want a double result. So I'm going to take the total divided by test scores.length. Right? However many test scores there were, divided by, I'm sorry, the total divided by how many scores there were. Great. Now I have an average, and we can spit out the average. Average score is plus the average score. Right? So this way, with this for each loop, the enhanced for loop, it's easy. Right? I don't need to do this index-based notation. There's nothing wrong with doing it this way. You could still do the exact same thing and take total plus equals the test scores at the index here. You're welcome to do that too. But this is less typing. And again, we're fond of less typing. As long as it's readable. The point at which less typing means it's really hard to understand when you come back to it an hour later because you wanted to go and take a break. And you come back to it. If you don't know what you're doing, it's no good. So some of the syntax is a little funny here, but after we practiced it a couple times, the syntax will make a little bit of sense. Well, no, okay, each one of these things is going to be called value in this collection of test scores. Great. Life is good here. We'll be okay. So let's give it a run, see if it works. So 3 test scores. Score number, let's do 100, 94, and 20. 71.33333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333833333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333more than 3 test scores when I run my program. Let's say, hey, let's enter 23 test scores. Why not? 1, 2, 3, 4, 5. I don't know. I can just. Oh, integer parseInt broke. Sorry, someone did not get 420, 225. You just did really well in the midterm. That's all. It's actually out of 1,000. No, I don't know. But right, as whatever value we give it here, it will make an array of that size. There is a limit because that has to be an integer value, so you can't have more than 2 billion or so. I don't recommend you have that many, right? But that's okay. So let me open up Task Manager here real quick. This is kind of fun. And let me run my program again here. All right, so if I say I want 2 billion, that's 2,000, that's 2 million, that's 2 billion here. So right now, I'm using 46% of my memory. So 2 billion times 4 bytes here should take up a decent number of bytes. We see my memory is climbing by IntelliJ IDEA, using more memory. Where did it go? Oh, did I lose it? There it goes. 9 gig of memory. But sure, it was able to allocate 2 billion 4-byte integers here. I don't know how the operating system did it, but it did it. It's kind of like magic. Again, we don't really care. We're kind of spoiled because the Java virtual machine does all that for us. It just asks the operating system that it's running on for memory, and then we say, yeah. If you don't have enough memory, it'll just crash on you and just fail. I had enough available memory, so sure, why not? Right, but you can see it went up, and then when this ends, here, I'll just stop my program. It all gets freed back up here. It all goes back down. Most of the way, I guess it was still using 2 to start, so sure. That was kind of exciting, right? So again, great. If I give it a bigger number than that, so on like, number format exception for input string. That's not even, that's too large for an integer when we do integer parse int here. Can't do that. And if I try and make an array, on an int array, too big equals an int of size here, it's just going to fail. The integer number too large. You have to be an integer. So there is a max here. But again, if you need more like 2 billion of something, I don't know what you're doing, right? You can do interesting stuff in data science and crunch a bunch of numbers. You don't load them all into one array in memory because that's just bad for the computer, right? You do other things, other approaches here. So you don't load 2 billion numbers all at once into memory, right? You just work on some of them at a time. So there's other approaches. You can learn all about that later on in computer science. That's fun stuff. Oh, I left my bottle too close here. All right, I've got almost 7 o'clock. Should we take a break? All right, why don't we take 10, and we'll come back and pick it back up with arrays. All right, so that puts us at 7:07. Alrighty. Welcome on back. Alright, so follow along in the text. Alright, hey guys, bring it on back. Bring it on back. So follow along in the text. We kind of got through section 1 and section 2. Not quite exactly. Yeah, we're going to come back to 6 for the GUI programming. Yep, so this is arrays. So we did creating an array. We did a regular loop. We did the for each loop. This variable arity methods, that's a really fun name, is cool. We're going to skip it. It's an advanced topic. Don't worry about it. It's interesting. You can like have a variable number of values passed in rather than an array of values passed in. Sure, it's fun, but not too big of a deal one way or the other. Array literals is nice. So if you know what the values are, like our first example for numbers here, I don't need to go through and assign them all one at a time. That's kind of slow. So I could make another set of numbers. So let's say, hey, this is an int array called other numbers equals, and I just in curly braces give it the values like 2, 4, 6, 8, comma. There we go. And I can just give it some values. So then this will be an array of size 4. Index 0 will be 2, index 1 will be 4, index 2, and index 3. All right, so this is a shortcut for creating arrays with known values. A shortcut, one word?
Yeah.
Really? It's not a shortcut? Okay, I guess that makes sense. It's a shortcut. Sure. Okay, so that's an option. You can make an array like that, which is nice. If you know what those list of values are. You can also say it's a new int and then give it the values. Sure, why not? That's fine. Cool, so that's our shortcut. One other thing you might see folks doing this is older style. You can put the array notation on the variable name. I don't recommend it, but you can. This is much more common. So you'll see it this way, and that's how other languages do it as well. For processing arrays, going through arrays, sure. You can use breaks, yeah, why not? So this makes an array of type player for this example, right? It doesn't have to just be ints or strings or doubles. It can be your classes, have an array of classes to go through here. Now, removing one is kind of obnoxious because if you delete it here, we want to like replace it with what came after it because you don't want to leave a gap in there. So you have some options, but if you just put the F in here, you can, and then we've got a gap here, or you can slide them all down by 1. Just a couple different options for how you want to work on things. Not too important one way or the other here. Assigning one variable to another here does not make a copy when you deal with arrays. So if I have an int array called copy other numbers, and I say, hey, this equals other numbers here. Not a copy here. What I get here is this array now is the same memory address as this array. So now I have 2 arrays pointing to the same location in memory. So if I don't have 2 arrays and I change one of them, they look like they both changed because it's not a real copy. So this just means 2 variables pointed at the same array in memory, right? Because what the variable stores is just the memory address. So when I say, hey, this array equals that array, sure, we've assigned the memory address here. We've matched. If you want a copy of it here, you have options to make copies, like this array's copy of will make a copy for you. This is the common way to make copies here. And you do other sorts of cool things with this arrays. You can fill them. You can arrays to string will give you a string version of your array very easily. So I don't even have to do the loop if I want. I can just get it all spit out that way. You can sort an array, which is fun. You can sort part of an array if you want to sort just from a given index to a given index. Don't worry about the binary search. We'll get into that later when we talk about sorting things. And then this random strings we don't need to worry too much about. He's got a big example. And then dynamic arrays, don't worry about. We don't need to do that one either. So we'll skip over that one. So that's about it for regular arrays. Okay. The next section is the array list. Again, this is my preferred way of doing multiple values here because they're flexible. You don't have to tell it, hey, you're size 5, and then you're stuck at size 5 forever. So, oh, and I did skip one thing. I'm sorry. So if you try and use an index that doesn't exist, so if we screw up this loop here and we say, hey, it is less than or equal to the length, and I try and get at the index that doesn't exist here, let's do that. You'll see a crash on you. So let's do 3 test scores. We'll do 100. We'll do 94, and we'll do 20. And now I get exception in thread main, array index out of bounds exception, index 3 out of bounds at line 38. You tried to get at index of 3. Remember, there is no index 3 when the size is 3. So these index out of bounds exceptions are going to be the bane of your existence for a little while until you get used to working with arrays and making sure we don't try and grab values that don't exist. It's real bad because there is nothing there at index 3. So the size of an int times 3 is not a memory address that belongs to the array. So Java keeps you from grabbing it. If you go take C++, C++ lets you do stupid things like grab a value of memory that does not belong to your array and do something with it, which most of the time is garbage. And then you get really bad stuff happening when you take garbage results, garbage values, and try and use them in your arithmetic. So Java is smarter than C++, or it's more protective than C++, I should say, and doesn't let you do bad things. So you want to get an invalid index? No, you just crash. Program crashes, game over. So if you get those, it means you're trying to get at a value that doesn't exist. All right, now we can do array list. So an array list, then, is a flexible array that you can add to and subtract from. It's dynamically sized. So to do an array list, you say array, capital L, capital list. This is a class here, and then you give it greater than, less than signs. This is the diamond operator, if you like technical terms. And then inside the diamond operator, you have to give it what type you're going to be using in the array. Now, you can't say int. This makes Java sad, because int is not a class. Int is a primitive type. Array lists only know how to work with classes because Java is sad. So instead of int, we would give it the integer class here. Java's okay with this because integer is a class. It knows what to do with classes here. This will be my array list of numbers. Right? And then because array list is a class that it does not come with the main part of Java, it's not in the Java language package that you get automatically imported. It says, hey, do you want to import this thing from java.util.ArrayList? Yeah, we want to import it here. So take the little light bulb suggestion. But yes, we want to import, alt enter. Come on, import the class. And then it'll add your import java.util.ArrayList at the top. Right. You can go type it in yourself. Again, I don't like typing things. So I like when the computer types for me. So we'll make this array list of numbers. Now, we need to create an instance of it. So I've told Java I want one of these things. It equals a new array list. Now, the shortcut here is you don't need to put integer again. You can just use the diamond operator, and Java says, oh, it's type integer because I know that. You can put integer here if you want. It's not going to hurt anything as long as you spell it right. It'll be okay. Sure. And it's going to tell you, hey, you can just replace it with the empty diamond. It's just going to tell you that it's not needed at that point here. So sure. So now if I want to add a bunch of values here, right, if you want to do that test scores thing again, or maybe instead of test scores, what can we ask for? What's another fun number to ask someone for? Sure. So we'll say, so we'll ask the user. So enter the number of deposits you have to track, or enter, I don't know, deposits you have. Sure. And then we'll get an int for number of deposits. Deposits equals integer.parseInt given keyboard.xline. Cool. Now I'm going to loop through this value. So when you create an array list, it starts empty because there's nothing in it. You don't need to tell it, hey, you have 10 values here. You just make one and it's empty. So my for loop here then is going to be for int, I don't know, index is 0, index is less than my number of deposits, index plus. Don't really need to use index here, but that's okay. I'm going to go ask the user, and I'm going to add the number. So to add something to an array list, you say your variable for the array list dot, and you get a bunch of things. You can add to a specific index. You can add all. You can give it another collection and add all of those items to it. You can clear it out, which empties all the things here. You can get the index of a given item in the array list. Say, hey, given this value, what's the index of the 7? That sort of thing. You can remove items by index, or you can remove them by value. Now this gets funny when your array list is of type integer. gets a little messy. So that gets a little awkward here, but that's okay. You can sort it. You can do all sorts of fun things with array lists. So add is what we're going to use here. So we'll add an integer.parseInt of the keyboard.nextLine. Next line. But we probably need to ask them here, right? So enter deposit number. Oh, here we go. There we go. So now we can use index, right? Plus index. So deposit number 0, deposit number 1, 2, 3, as many as they have here. We'll go and add them. So add just adds the value to the end of the array list. I don't need to resize it. I don't need to size it to start. It will just, if I have 1,000 values, it will just let me add 1,000 values. It's flexible that way, which is really nice. And that's why I like array lists better. When we're done here, right? So we're going to print my array list of numbers. Sorry, do that one more time. So we'll print the array list of numbers when we're done. So I have 0 test scores to enter. Average score is NaN, not a number. You divide it by 0. A double divided by 0 is not a number. At least it doesn't crash. All right, so how many deposits do we have to enter? Let's just do 3. How much money are we putting in the bank? It's imaginary money. $100, $2, and $1,000. Now this, when we print my array list, actually gives me some values, right? I get the values comma separated with square braces. If you remember back to the arrays from the last chapter, it said when you call arrays to string, it'll give you something that looks like this. Sorry, that's all the way down at the bottom, isn't it? It's sort of up higher on that screen, but now you gotta like twist a bunch. Sorry. They're gonna renovate L building in time for all of you folks to graduate, and we'll move all of our CIS classes over there at some point. I'm sure you're excited to have a renovated building after you're gone. Thanks for paying your tuition. But you know, sure, they got to start somewhere. Yeah, the parking lot renovation that cost $500,000. Yeah, to renovate the parking lot, it was ridiculous. Paving it, like cement, is expensive apparently. So yeah, sure. So a real good use of money, I'm sure. All right. So printing it now just works nicely for us, which is handy. It's a nice little shortcut. You can see the values here, but you can still do those loops. So if you want to use an index-based loop, so for int, index is 0, index is less than. Now with an array list, you don't have a length property. There is no length, but you have size as a method. So size gets parentheses because this is a method call, because an array list is a class. Arrays themselves just have a property here, an attribute called length. It's not a method. So length does not have parentheses, but size has parentheses because it's a method call. It's going to be awkward for a while, but if you just try and use, like, if you try and do length with parentheses, it yells at you. Says, I don't know what this is. Method call expected. Doesn't exist. Or if you try and do size without the parentheses here, it yells at you as well. So size has private access. That just means you have to use the method here. So sure. So here's size, and then index plus plus. We can loop through and print them all out. So this is, I can say my score or deposit number plus index plus colon plus, and then I want, now to get a value out, you don't use the square braces because this is an array or an array list here. So it's array list of numbers dot get, and you use get given the index value. So get is the same as the array notation to say, hey, I want something at this location here. Now what's fun with arrays, this is both the set and get version here. So I can set something using that notation, or I can get the value using that notation. With an array list, this is only getting. You can't change the value by saying, hey, array list of numbers dot get something equals something else. It doesn't work for you. Right? That's why there's a set method if you want to change the value. Just a couple differences here. They're important. So we'll get the value at that index. Again, if you don't want that, you can do the enhanced for loop or the for each loop. We can say for int value colon my array list of numbers. This also works here, and you can just print out the value. Again, we don't get any of the other stuff. There's no index that I can say, hey, this was deposit 0, this was deposit 1, this is deposit 2. It's okay, but we can do like the same totaling. Maybe I want to total the numbers here, and again do an average. So what's your average deposit? Sure. It's kind of boring to do it again, but we could. Oh, let's do a different one here. So let's say, what is the largest deposit? if I give you a bunch of numbers, like if I'm going to tell you 10 numbers, how do you find the largest one before you write the code for it? What would you do? Yeah. We could sort them. Can we do it without sorting? Yeah, so we have to compare and see if we find a bigger number. So in your head, if I start listing off numbers like 10 and 5 and 3 and 12, you know which one is the biggest, right? What did you start with was the biggest number? What was the first biggest number? 10. It's the first number I said. So to get the largest number here, this will be the largest number, is going to equal my array list of numbers dot get 0. It needs to start at something, right? So it's the first value, right? This is the first value. The first value is the largest until we know otherwise. Right? Now I can compare the largest number to the other values because you have to start with something. So I can say, okay, hey, if my array list of numbers, if the value is greater than the largest number, then the largest number should equal the value. That's it. For every value, let's see. If it's bigger than the largest, I have a new largest. If it's not, nothing happens. Right? So 12 became the largest. I could list off a bunch of numbers smaller than 12, nothing happens. As soon as I say 15, 15 is larger than 12. Now the largest value is now 15. We just keep on going. When we're done, we can print out the largest value. Largest deposit is plus the largest number. Let's give that a shot. So finding the smallest works the same way. You just go less than instead of greater than. Right. So 0 test scores to enter. Sure. 3 deposits. What do we do? $100, $2, and $1,000. Deposit 0, deposit 1, deposit 2 using the index notation, and then the largest deposit is 1,000. Right. 0 or 100 was the largest. 2 was not larger. 1,000 is greater than 0. And you can put a breakpoint in here. You can run it in debug mode if you want. Right. We can run this in debug mode and watch it. Debug mode is awesome for these things because you can actually expand the values and see what you have. So let's do test scores. We'll do 100, 94, and 20. And then 3 deposits, 100, 2, 1,000. So in debug mode, I have numbers here, right? 7, 13, 17, 23, 29, 31. It shows you what the values are, or you can expand it to look at by index here. Right? The other numbers, 2, 4, 6, 8, and the copy of other numbers, it's really hard to see, but on the screen here, it says at 974, at 974. They're the same memory address. Remember, we didn't make a copy of it. We just have 2 variables pointed at the same location. They're the exact same array, right? And by looking at the memory address here, we see they're the same. And then I see test scores, right? 100, 94, 20. Right? Those are the test scores we entered. My array list of numbers doesn't show me the values until I open it. Once you open the array list, expand it, now I can see here's the values. So arrays kind of show you the values right here if they can. Array list you have to open, but sure. You can expand these ones too, like to see what the value is, but it gives you the value right here anyway. So like the other expandable arrow is kind of silly at this point. It's nice if you have an array list of classes, because then you can open that class and you can see what the attributes of that class are. Because right now it's just giving you the string representation of it here. But in debug mode, we can see what the values are, which is really fun. All right. Cool. So let's see. So array list gives a type here. That's the parameterized type. This won't make any sense until you get to next class, 2151 or data structures 2353. We'll spend a lot of time looking at these parameters. Yeah, we don't really care too much. It just is of that type here. This idea of wrapper classes, right? The integer and double are classes that wrap around the primitive types. So Java just works for you. You can do all sorts of fun things with integer class versus int, but it's not too big of a deal. It just works. But just if you try and make an array list of that type, it will just fail. So if I want array list, where'd it go here? Where did I make my array list? Here it is, of type int. It just doesn't work for me. Requires a type. Okay, put in int. Does it work now? Didn't think that would work. Now I'm confused. It didn't use, okay, no, okay, good. Now it fails. So it'll compile, it just won't run. So that's ugly. Sure. Or is that not even compiling? No, it won't compile. I just don't get errors. Why don't I get errors? Here's my to-do. My errors. No? Huh. That's really weird. No red lines, but so it has to be the class value here, right? Using those wrapper types, integer, double, that sort of thing. Using ArrayLists, great. ArrayLists of integers. Again, if you want to have 2 lines of code, go for it. You have 2 lines of code. You use get. He likes I. Go for it. That's fine. I just prefer integer. Yep, cool. We're going to skip records. Don't worry about records. They're fine, but it's okay. Not too big of a deal. You can come back to it later. We're going to skip searching and sorting. 2-dimensional arrays. So one of the fun things we can do here is we can make an array of a given type. The type that it can be is a type of another array. Start to hurt your head a little bit, but think of like an array is just a bunch of items in a row, right? If you have an array of arrays, you have rows and then columns. So I can make an array or an integer array. This is my 2-dimensional numbers equals a new integer array, and then what? This was how about 3 by 3? So I have 3 rows, and each row has 3 columns, essentially. So you can kind of imagine it like 1, 2, and 3, 4, 5, and 6. Oh, we should do indexes. Oh, that's fine. 4, 5, and 6, then 7, 8, and 9, right? So the integer array here, the row, is another array. So really, all of these get put in a single line here, but it's kind of hard to imagine this in a single line. 4, 5, and 6, and then 7, 8. Where's my commas? 7, 8, and 9. Want more spaces? No, that's fine. It's probably fine. So you really get this, but it's easier to imagine it as 2 and 3, with each of these being an array here. It's not actually 2-dimensional, right? It's easier for humans to think about things in 2 dimensions than it is what's the first value and then what's the second value, right? We like things like this because this makes a lot of sense to us. Now, I know you're thinking, because you folks are all super smart, well, if you can do 2 dimensions, can you do 3 dimensions? Sure, go nuts. So int 3-dimensional nonsense. It's an int array, new int 3 by 3 by 3. Sure. At this point, I don't know how to picture it in my head. I can kind of imagine, I think of like a Rubik's Cube, and then my head just starts to hurt because like you have rows, you have columns, and then you have like a depth that you can go beyond or like a height that you can go beyond. It really starts to hurt my head. You can do 4 dimensions if you want. You can do 5. I forget what the actual limit is, how many dimensions you can do. I don't ever recommend you even do 3 because it's hard to visualize in your head. And if it's hard to visualize in your head, it's going to be hard to work with, right? Because we write code for us to understand. So there's probably other ways we could store data that is not a 3-dimensional array nonsense something. But you could if you wanted. You can do really ugly things with code. Java's not going to stop you, right? Humans will be upset with you because we won't understand what's happening, but that's okay. So 2 dimensions is about as far as we get, and this is relatively common because a lot of things are 2-dimensional, right, with rows and columns. Right? If you think of any sort of spreadsheet you've ever opened up in Excel, you have rows and you have columns. Sure, that sort of makes sense in our head. So what we can do then is we can make like a tic-tac-toe board, right? So I can say, instead of this being an integer array, this is character, right, for just X's and O's. You could do strings if you wanted, but characters are a little easier for just X's and O's, I think. So this is my board equals a new character array, 3 by 3. Sure. Now, again, I can assign them one at a time here. So I need to give it the row index and the column index. So I'm going to say my board at row index 0 at column index 0 is equal to an empty space, because I want to fill out empty spaces to play tic-tac-toe. Now, you're hopefully thinking I'm going to copy paste a bunch, and this is really silly because it's really redundant code here. And yes, you are correct. You don't want to do this by hand. You can. Nothing's wrong with doing it by hand other than it's a lot of work, right? And it'd be easier to just use a loop, but we could also, just to illustrate. So This is row 0, column 0, row 0, column 1. So this is row, and column, right? For imagining what this equals in our head, rows and columns, right? And it works out. The first array here, which is the array of arrays, what index is it here? So if you imagine it just longwise, is it index 0, is it index 1, or is it index 2? Right? Which value in the outer array is it? And then which column, which value is it in the inner array? Index 0, index 1, or index 2? Right? This whole array is index 0. This whole array is index 1. This whole array is index 2 of the rows. The inner value is the columns. So any way you want to imagine that works well in your head. That's fine. And then one more here. So this is board 2, 0, 2, 1, and 2, 2. Sure, now we have an empty board. Now that's a lot of work, right? And it's fine for tic-tac-toe, but if you want to do something larger, like play Connect 4 or something, you probably don't want to do this 42 times because it's a 7x6. Sure, but we got options. So a loop is better. So I'm going to say for int. Now, what a lot of people do, and I hate this, they'll say I is 0, I is less than, now it's my board.length is the row length, the number of rows that I have, I plus plus, and then they do another loop. They say for j equals 0, int j equals 0, j is less than the board at the index dot length. This one's important because you don't have to be a square, you can be a rectangle, right? Like a Connect 4 board is a rectangle, 7x6, it's not a square. You could be a square, but you don't have to be with a two-dimensional array. This is j plus plus, and then they say my board at I at j is equal to a space. Now, I don't know about you, but I and j look awfully similar. Maybe I'm just old and I have a hard time seeing things. But I hate when people use I and j, and I will make fun of them so much and like make fun of their code and say that's awful, it's terrible, you need better names. And yeah, it's not hard to have better names. So instead of I and j, I'm going to use row index and I'm going to use column index because that's literally what these are. And then you can nicely see in my code that you have row index and you have column index, right? Not hard to type this sort of thing here. Row index, column index. And now board at row index, at column index. I like to imagine this is a lot nicer and easier to follow for someone reading a two-dimensional array. You see this is the row, this is the column, rather than I and j. Everyone does I and j, and I hate it. So my goal in life is to make sure no one ever uses I's and J's after my class. It's okay. It's a silly goal to have, but it's one of those little things in life that would make me happy if people stop using I's and J's because they look the same to me. All right, so we could use a loop. This is much easier then to assign them all a space than it is to do one at a time. But both work, right? Either option's okay. Does these make sense with row index and column index versus the index of row and column here? Both ways give me an empty board, right? Cool. So this is a two-dimensional array. Now we can also do two-dimensional array lists. Again, I prefer array lists, but this starts to get really wordy here and really verbose. So if you want a two-dimensional array list, it's an array list of type. Well, what type? What is the outer, what are the rows made of? Well, the rows are made of array lists of type integer. So it's an array list of integers. This is my array list board. Equals a new array list of, now the fun thing here is you only need a single diamond because you only need the outer type. It knows that it is a type of array list of integers. Now the problem is when you make an array, you tell it what size it is, it's 3 by 3, it's already done. When you make an array list, it's empty. It's not there. So I can't say, hey, array list get index 0 dot get column 0 or set index 0 set column 0, right? You can't get at things that don't exist yet. So we need to go and make them. So this starts empty. So it gets a little trickier to use an array list of array lists because it starts empty. So I'm going to say for int row index 0, row index is less than 3 because I want 3 rows, row index plus plus, right? Because I need to make the rows because they don't exist yet. It's empty. So to make the row, I'm going to take my array list of board and I'm going to add a new array list. And again, you don't need to tell it the type, but it is of type integer at this point here. And again, it's telling me that you don't need it. Should I just leave those out? I guess I can just leave them out. So I've added an empty row here. Right? So this adds an empty row. Now that I have an empty row, I can add the empty columns, those spaces here. So I need another loop then. So for int column index is 0, column index is less than 3, column index plus plus, I can take my array list dot get my row index. This will give me back the array list that I just added here, the empty one. From here, then, I can go add, oh, I'm sorry, not integer. This is type char, character. Sorry. I don't know why I was doing it. I have an integers on the brain. So I can add an empty character. This is why this is a little uglier. And people tend not to like array lists when we do stuff like this, because I'm getting the array list row, and then I'm adding the column to that row. It gets really wordy looking. So this is a little harder to follow. I admit that, even though I like these better. So this gets the row at the row index and adds a, right? So this is filling out all the columns for each row. So ArrayList board.get row index will be the same row index 3 times. It's still row 0, index 0, row index 0, row index 0. 3 times I'm going to add a space. Great. And then this loop finishes, right? I go back to the outer loop, row index plus plus. Row index is now 1. Add a new array list, add to the end here, which will add one now at index 1. Now that index exists, now I can go get it, add a space, get it, add a space, get it, add a space. This is going to be a little funny to follow, but it works, I promise. Right? So we're done. We can print out my array list board. Let's give this a run. So 0 scores to enter, 0 deposits. Uh-oh, oops. We can't get 0. Oops, that's right. We tried to get the 0th index out for the largest deposit. Okay. So when I print my array list of board, it prints it as a single dimension, right? And each one of these, then, here's the array list there. That's index 0. This one's index 1. This is index 2. 0, 1, and 2. You're doing software engineering, tic-tac-toe, and JavaScript. Nice. JavaScript is fun. Not Java, though. And it's just badly named years ago, and the industry has never changed it. Which is also sad, but that's okay. All right, so this is my empty array list. Now, these actually debug really nice as well. So if we run this in debug mode, put a breakpoint in, run the debugger. The debugger is your friend, by the way. Definitely your friend. So I see my array list board here is size 3. I open that up here. Now, this is why that expanding for the value is useful, right? My first array list of numbers here, sure, I don't need to expand this further. But now, what is index 0? Well, index 0 is another array list. So if I open that one up, I can see the array list here. And then what is 0? The value is a blank space, which is the number 32. Remember, we actually store these Unicode values, that the numbers that correspond to the character. I think we talked about that way back when we forgot about it ever since. So you can open it up and see what all the values are. Right? Debug's just the same. Hey, Sniffles, yeah, I'm behind on grading with the power outage. I'm sorry. I wanted to get it all done during break, and it didn't happen. So I'm still behind. The good news is, though, that because I'm so far behind, I will be much nicer to you folks for grading wise. So it's in your favor. I apologize. I know that sucks to have to wait and be worried about all these things, but the projects you scored yourself, right? Because you looked at the rubric and said, yes, I did it, or no, I didn't do it. So hopefully you know how you did on the projects. And if you gave the lab a good college try, a good effort, you're going to get the points for it. The labs are your practice. The labs are not meant to penalize you. The labs are your way of practicing, getting some time in, making sure it's working for you. You're kind of measuring stick, am I getting the material or not? So if you got at least like half of the lab done, 3/4 of the lab done, you'll get the whole points. No worries there, right? If you turned in like 2 lines, no, there's no points there. But if you gave it an attempt, I'm going to give you points for the lab because it's your practice essentially here. Okay? Yeah, thanks for asking. Yeah, it thought it was a link or something. I don't know. It blocked stuff out. I'm sorry, Sniffles. Yeah. All right. So array list of array list works. It's okay. So what we're going to do is we're going to actually make a tic-tac-toe game here. Because why not, right? We have the board already. Now, what we want to do is we want to build this as a class, right? Because it's a noun. Tic-tac-toe is a noun, right? It's a proper noun. It's a game here. So what are things that we would do with tic-tac-toe? What are ways that we would interact with it? So we know its attributes is the board. Does it have any other attributes? Does tic-tac-toe know anything else or have another attribute other than the board? Like it probably knows who the current player is, right? Either X or O. That's probably all tic-tac-toe needs to know, right? So if we go add a new class here for tic-tac-toe, right? We'll have a private char of current player. X probably starts, right? And then a private array list of type array list of type character called the board, right? Oh, no, I'm sorry, I shouldn't give values here. Sorry, we declared the values. We'll make a constructor. So public tic-tac-toe, right? A class constructor. We don't need any arguments here because we know how to make a tic-tac-toe board. We don't need to be told anything here. And then I'll set current player to X. And then I'll set my board equals a new array list. A new array list of diamond here. Give me the import here. No? Why is it not yelling? Sure, that's fine. Now we'll go through and copy. So I'm going to go. Oh, it didn't put it in the right spot. That's weird. I needed to add it to source. Now it's happening. Okay, array list import. It wasn't in the source folder, so it wasn't actually thinking it was a Java program. It got really confused. So I just moved it into the source folder, and it's happy now. That's what that was about. All right, so add the import here. Great, and yeah, now we get our cool coloring. We can see those are the purple attributes here. Life is good. So we'll go steal this copy here. Out. And now this is just board and board, right? So make a new array list and then add 3 rows, add an empty row, add 3 spaces. Add another empty row, add 3 spaces. Add another empty row, add 3 spaces. Great, we've got our tic-tac-toe board. Now our game's ready to play. So ways that you interact with tic-tac-toe, right? You tell it where you want to mark, right? So public, now I'm going to have this be a Boolean attribute, either a true or false, because you might try and mark an invalid spot, and I'm going to tell you no, right? Or if you give me a good spot, I'll tell you yes. So this will be a Boolean method here for mark, given an int row index and an int for column index, right? So you tell me, hey, I want to mark 0, 0, I want to mark 1, 1, I want to mark 2, 2, I want to mark 2, 0, whatever, right? As long as you give me valid indexes, we're good to go. So right away, I'm going to check to make sure that it's valid. So I can say, hey, if my row index is less than 0, or the row index is greater than or equal to 3, or the column index is less than 0, or the column index is greater than or equal to 3, we can just return false right away. You gave me a bad index because I only have 0, 1, and 2 for row, and I have 0, 1, and 2 for column. Right? So 3 by 3. Index 0, index 1, index 2 for those 3 values. So real quick, make sure they're valid. Then I'm going to check to make sure that it's empty. Now at this point here, I can just use the characters, like add this here. Probably not too bad here, but we also could add those as static values or like a constant value, which is probably a nice thing to do here. So I can say this is a private constant char for empty equals empty here. Nope, not constant, sorry, final. And a private final char for, and this was kind of silly to have X as a character, but sure, I can do X. And a private final char for O. Then O. So this way I have names for my values. Anytime you have a value more than once, it's possible you're typoing it. So if we use a variable, I'll always get the exact same value every time, and maybe I won't do uppercase versus lowercase and screw things up. Because that's really easy to have happen. So this is just a safety feature for yourself. Let's go give some values here. So then instead of adding this, I can just add empty. Right? This is my empty attribute here. Okay, so then I want to check and say, okay, now that I know the indexes are valid, if my board.get the row index, .get the column index does not equal empty, if it's not empty, then I'm going to return false. You can't go there. Right? Now, you're welcome to leave it here, but you also could then go put it up here as well if you wanted. Because if the index is invalid, because we're ORing all these things together, it will never attempt to get here. Remember, ORs will short circuit. The first time it sees a true, then it just says, sure, the whole thing's true. It doesn't even need to look at these other values. Right? So if I gave it row index of like 10, and I tried to get row index 10, it would crash. I get array index out of bounds exception. but it's never going to try that, because if it's 10, it's more than or equal to 3, the whole thing is true because I'm ORing these together here. It'll just return false and we're done. So this is checking inbounds and, oh, I'm sorry, and it is, no, if it's not empty, it's false. Okay, so if it's not empty, we just get back false. If it is empty, now to set a value here, I'm going to say board.get the row index. In that row, I want to set the column index to the current player. So set is how you change a value. We don't use the square brace notation like we do with arrays to say, hey, index 2, you get a new value. We have to use set and say what index, what value. Right? So if board were an array, it'd be board of row index at column index equals the current player. Right? That would be the notation for setting a value using arrays, not array lists. With array list, you have to get the row, which gives you back the column, right? Or gives you back the row, and then you can set the particular column based on index to this value. So hey, get row 2, set column 2 to this, or get row 1, set column 1 to that. You always have to start at the middle. The middle's the right place to go when you play tic-tac-toe. My kids don't play with me anymore because I never let them win. My wife says that's mean, but like, why would I lose a tic-tac-toe to them? I don't know. They need to learn how to like not lose a tic-tac-toe. I don't know. Like, it's not ruthless. Like, this is what it is. I don't know. It's perfect. Yeah, well, that's true. Life is not fair. We should not tell people life is fair because they'll be very disappointed later on in life when they find out it's not fair.
When you beat them, you look at them and go, O'Doyle rules.
O'Doyle rules. Oh, I tell them they should have gone here instead. And eventually they just stop playing tic-tac-toe with me because when you have when you tie every game, it's really boring.
It's good.
Like, sure. All right, anyway, so we're going to set the value. If we set the value, then we can return true. It worked. Oh, but the other thing we need to do, we need to change current player. So we can say, hey, if current player is equal to X, then my current player can equal O. If it's not X, then the current player equals X. Right? This is a pretty easy use case for those ternary expressions I said I hate. Remember where you like give it the question mark and a colon? You can do that if you want, right? So you can say current player equals X question mark O colon X. Is that? Nope. Sorry. Current player equals current player. So this is why I hate these though. Like this looks like garbage. We're saying if current player equals X, then give it O. If it's not true, give it X. Right? I just like this better, but you can do this if you want here, right? Sure. And we'll return true. It worked. Okay. Now the other thing a tic-tac-toe game should know is if someone won, or if the game is over, right? We can ask, is the game over? So we can have a public Boolean is game over function. So to know if the game is over, it's either a cat's game that's tied. I don't know why they call it a cat's game, but that's what you call it, right? Put a big C on it.
Yeah.
I don't know where that came from. It's tied, or somebody won, right? So we're going to return is tied, or someone won, right? We're going to do this functional decomposition. We're going to break a big problem down into smaller problems. I don't want to do both at once, right? I want to solve them one at a time. Yeah, this is what we want to do, right? We want to solve these one at a time here. Okay, so how about, now, is tied here? We could make that a public method. It also could be a private method, depending on how we want to do. It's probably fine to make public. So we'll make this a public Boolean is tied. Now, if the game is tied, that means nobody has won and there are no spaces left, right? So if I find a space, the game can't be tied, right? Or if somebody won, the game can't be tied, right? So real quick, we can say if someone won, if someone won, then we're going to return false. Because if somebody won the game, we're not tied. If nobody has won the game, then now we're going to look and see if there's a space here. So we can say for, now this gets a little silly, but we're going to loop through my board and look for a space. If I find a space, I'm going to return false because there's still somewhere to go. Okay, so to loop through the board, I'm going to say, okay, this is for ArrayList of type character called the row in my board, right? Because the board is made of array list of characters. It's an array list of array list of characters. So each row is an array list of character. Then I can say for char, I don't know, mark in the row, right? Get the individual character out now of the row. And if the mark is equal to empty, return false. It is not tied because we found an empty space. There's still room for someone to move. Okay. If I've looked at every mark in every row and I haven't returned false, then I can return true. The game must be tied because I did not find an empty space. So it must be tied at this point here. Right. So this only runs if didn't find an empty space. Right. Then we get to here. As soon as it finds an empty space, we return false. The method stops. Right. So this is just ending as soon as it finds a space here, given a mark in the row. Right. So if somebody won, no, it's not tied. If we find a space, no, it's not tied. If nobody won and there's no spaces, it must be tied. Right? Okay. So now somebody won. So again, this could probably be public. Someone could ask if there's a winner versus if it's tied to know somebody wins. Sure. So public Boolean, someone won here. Now, to find out if someone won, you can win by row, you can win by column, you can win by diagonal. So we'll do that. So we'll return someone won by row, or someone won by column, or someone won by diagonal. Diagonal. Right? Take a big problem, break it down into smaller problems. It's hard to do all of those at once, right? That's 4 different things to check. Because you got this diagonal, you got this diagonal, you got 3 different rows and 3 different columns to check. Sure, let's break it down. Now these can be private. We don't need someone to be able to check if you won specifically by row or not here, because no one really cares at that point. They just want to know if they won or not. So these will be private Booleans for someone won by row. Now for now, I'm just going to put false for a second here. I just want this to compile. And I'll come back and finish that. So private Boolean, someone won by column, turn false here, and then a private Boolean, someone won by diagonal. And it's suggesting them to me because it knows I need the method. Right? I was trying to use the method that didn't exist before. So now at least we'll compile. But now we can go and finish these. So if you win by row, then all 3 characters in the row have to be the same thing and not a space. Now I could check for X's and I could check for O's separately. I'm lazy though, so I'm going to check if all of them are not a space and the same. Right? So we can say for, this is an array list of type character called the row in the board. So for every row on the board, if my row.getZero does not equal empty, right? And row.get1 or get0 equals row.get1 and row.get0 equals row.get2. 2. Right? So for not empty, and 0 matches 1, and 1 matches 2, or 0 matches 2, right? It's not empty, and they match, and they match. If that's true, I'm going to return true. Somebody won. X is 1 or O is 1. I don't care who. I didn't want to figure it out at this point, right? Okay, game over. If we go through all of the rows and haven't returned to true, then there is no winner by row. We can return false, right? Same thing with column. I'm going to look at this column, and this column. Now this one, I can't do a loop over row, right? Because I need to look at all of the rows at once here. So this one's not as pretty, but it's okay. So we're going to say for int. Now I'm going to look at column 0. I'm going to look at column 1. I'm going to look at column 2. I think I'm backwards to you folks, right? So we're going to say this is my column index equals 0. Column index is less than 3. Column index plus plus. So we'll look at each column one at a time here. Oops. Okay. So if row 0 column index is not empty and it matches row 0 matches row 1 and row 0 matches row 2, same idea, right? So if my board.get, now I know it's row 0, right? I'm always looking at column 0 to start because what's changing here now is the column. I'm sorry, The row number is always 0 because this is the first row. The column number is changing. So row 0, column 1, column 2. If that's not empty, right? And then that they match. So now I want row 0, column 0 matches row 1, column 0, or column 1 or column 2 as we're looping through, right? This is my matches here. And 0 matches 2. If all of that is true, then I can return true, right? It's not empty, and row 0, column whatever, matches row 1, column whatever. And row 0, column whatever, matches row 2, column whatever. Right? We can return true. If we've done all of that and we didn't get something, we can return false. Right? You okay so far? Now, the winning by diagonal. You can do a loop here, but this is tic-tac-toe. There's only 3 spaces. So the loop, I feel like, is harder than just looking at the 3 spaces at 0, 0, 1, 1, and 2, 2, or 2, 0, 1, 1, and 0, 2 for your indexes. I've done it a lot. I know how those indexes work, so I feel like it's easier. You're welcome to use the loop, but I feel like the loop just gets harder anyway. So we're going to say, hey, if my board.get1.get1, this is the center space here, right? Because both diagonals need the center. So if the center is not empty, right, then I know I can match this diagonal or this diagonal if it's not empty. If it is empty, there is no winner by diagonal anyway. We're just going to be done here, right? We're done right away. So if we're not empty, and now I have 2 cases. I have this diagonal and I have this diagonal, right? So I'm going to do another set of parentheses here. So board.get1.get1 is equal to board.get0.get0, row 0, column 0. If that matches 1, 1, great. That's the first case here, right? And 1, 1 matches 2, 2. Right? That's the first diagonal. 0, 0, 1, 1, 2, 2. That's this diagonal here. Okay? So that is one option here then with this set of parentheses. So if we're not empty and this is true, or another set could be true, right? This diagonal or this diagonal can be true. So like all of this then gets put together in another big block here. It gets a little ugly here, and you could break it down further into separate diagonals if you want, but I think this kind of works out well enough here, right? So that's that one, and then board 1 matches. Now it's row 2, column 0, right? To go from the bottom row going up, row 2, column 0, 1, 1, and then row 0, column 2. So row 0, column 2. So all of that then is this OR here. Oh, do I have too many? I think I have too many. And then that ends the ANDing here. And then all of that ends that one. Let me try and reformat that here real quick. Format code. So I don't like how this formatted here. So I kind of want, I'll just put this all on one line here because it's going to be a little long, but again, I'm zoomed in. And I think I just want this to like make sense visually here. So all of that is true, or all of this is true. Oops, too many. There we go. And then we've got too many of those suckers here now. Oh my goodness. Okay. This is ugly, I'm sorry. Right, but if this is true, and this is true, or this is true, right, with that set of parentheses here. I don't know a good way to lay it out here. It's a little funny looking, but does that make sense? So if all of this is true, I can return true. Now, at this point, though, if you're saying if something is true, return true, let's be lazy here and we'll just return that value. I don't need to say return true, else return false. I can just return this value. And then I don't need this other set of parentheses. Does that make any sense? Right? Because this will either be true or false already. I can just return that true or false. If it's not empty, that's true, and this has to be true or this has to be true, right? If it's not empty and this diagonal matches or this diagonal matches, we're going to return a true. If it is empty, we're done. We just return false right away. Otherwise, we'll check either this diagonal or this diagonal because we're ORing those together. Get a little long there. So that's our tic-tac-toe game, right? So to play tic-tac-toe then, right? Does that still have errors to do? My errors. Where do I have errors? Up here. Too many parentheses. There we go. Too many parentheses. Okay. So to play tic-tac-toe over here in main, then, right? Let's do that at the top because we'll. Oh, I forgot to be committing all along here. So this is. Let me skip that one. So here is 2D or array lists and 2D arrays, array lists, and then here's tic-tac-toe. Great tic-tac-toe. We'll commit that one. So now let's actually play tic-tac-toe. So to play tic-tac-toe, we'll say tic-tac-toe equal I don't know, game, sure, equals a new tic-tac-toe. And then we want to loop. We want to say while game dot is game over, and we want not the game over. As long as the game is not over, we want to keep on playing. So I want to use this scanner thing. Where did I do scanner? I'm going to move this up top here so I can use scanner. Okay. So if the game's not over, we want to keep on going. So let's spit out here. How about game dot? We need a get current player. Right? We don't have a method for current player. So let's go generate some code here. Right? We can write it ourselves, but we might as well just let it generate it for us. We need a getter for current player. So in main, I can say game.get current player plus his turn. I don't know. Sure. So somebody's turn. We probably also want to print the board, right? Show them what the board looks like. We don't have a way to do that currently, because if we just print the array list of board, it's going to be really ugly. So what we probably want to do here is we want to override the toString method. We want to be able to way to just take tic-tac-toe and throw it in a string version here. So remember, we can use this at override public string toString. Say, hey, I want to override the string toString function of the object because everything inherits from object. So to do this, it gets a little funny here, but we want to take each row and add it to a result. So I'm going to take a string for the, I don't know, result. It's going to start as empty. Then I can say for array list of type character called the row in the board. Let's take my result plus equals row.toString. And then at the end of that, I want to add a new line character, this \n, because I want to go down a line and then go down a line. So taking a row to string will give me the square braces. It's not the worst thing in the world. It's probably okay at that point. We'll have the square braces in there, and then they're comma separated. It won't be the prettiest. We can make it look prettier later, but this ought to work for now. When we're done, we can return the result. So we should print the board and say somebody's turn, right? So we can just print the board. We'll print the game because we have the toString method. We'll say somebody's turn. Then we'll ask them where do they want to go, right? What row and what column? What row, what column do you want to mark? So we need an int for row index is integer.parseInt given the keyboard.nextLine. Next line. Sure. Oh, we need to ask them, right? So what row index? And I'm going to tell them, right, 0 to 2 because they're not going to remember it's 0 to 2. We'll get the row index, and then we'll ask for the column index. What column? Index 0 to 2. This will be my column index. And then we'll try and play. So we can say, hey, if game.mark the row index, the column index. I don't know, really, if it doesn't mark, if we get back a false, then we can spit invalid. I'll try again. Right? If you marked here and it was invalid, nothing changed with current player. So we just go back up to our loop here. So we're just checking to see, to give them the message that it was invalid, and then we'll let them try again here. If it was valid, it will change current player, and we'll put the mark on the board. When we print the board, it should work. And this just keeps on going as long as the game isn't over. So when the loop is done, we can print out game over. Now we probably want to print the board game one more time here, right? Say game over and then print the board one more time. So let's try it. So here's the empty board. Again, it's not the prettiest tic-tac-toe board. We need like the lines and stuff, but we can do that after. So it's X's turn. What row index? You guys be X, I'll be O. If you beat me, you can go home. 0. What column? 0, 1. Okay, so you win an X here. All right, so I'm going to go in the middle. So I'll go 1, 1. All right, X's turn. Where's X going to go? What? So it's 0, 0. So 0, 0. Okay, well, I got to block you, so that is row 0, column 2. You're going to go here now, right, to block me?
Yeah.
So row 2, column 0. All right, well, I have to go here to block you, so that's row 1, column 0. Now you have to go here to block me, so you're at row 1, column 2. Now, it doesn't really matter where I go. Game's over. Game's tied, right? I'm going to go here because it'll be nice symmetry. So I'm going to go 2, 2. So your turn. So you go 2, 1. Game's over. We tied. And we have a cool pattern at least, right? Sorry, you're stuck here. You didn't win. Right? And we can put all of this in a loop. Hey, do you want to play again? And make a new tic-tac-toe game and let them play again if we wanted, right? Now, we didn't actually try to see that an invalid index was invalid. Probably want to make sure that works, right? So let's try it again and say, how about like 5, 5? Invalid, try again. Still X's turn, right? So like life is good. We want to test it out here. That make sense? So we're having fun with this 2D array, right? An array list of array list or an array of array. You could write it with an array of arrays if you wanted here, or you could write it with the array list of array lists like we did. Okay? All right, why don't we talk about the lab and then we can break if you want here. And that way you don't have to wait 10 minutes to find out what the lab is and go home if you're bored. All right, so we just want to practice with these things. So we're going to take tic-tac-toe and you're going to write it with an array version rather than array list version. So we have to use that square brace notation, right? Instead of the get notation, right? So with the array, two-dimensional array, right, you had just these square braces for board here. And then you would get square brace for setting values and for getting values. Right? You use the same notation here for setting and for getting. Okay, that sound reasonable? So let me go post that for you real quick. And that's the last section here is 2D arrays, doing fun things with 2D arrays, right? You do fun things with 2D arrays. This game of life is really neat here, but that's fine. You can do all sorts of cool things. So again, checkers, the sort of thing, right? We're not ready for that yet, but we could do checkers later if we wanted. All right, so let me go make the link for you here. All right, so this is lab 6. 200, lab 3, lab 6.
I have one of those.
Java template.
This is not fun. I mean,
I need to push this. Here's game tic-tac-toe. Did that change? Oh, I added the 2 string. Okay, that's right. Push. So lab 6. That'll be due next week. 10 points for lab 6. Come on. It's like so many clicks for this. So use the tic-tac-toe game from class. Modify it to use arrays instead of array lists. All right, and then we'll turn this in. Submit the URL to your repository. All right, and then let me just get the link for that for you. So this is on GitHub. All right, awesome. So we got the rest of the night to work on this. The next project is due next week. Remember the project 2 for electric vehicles? And that's what we got tonight. Thanks, folks. Thanks for hanging on the line, everybody.